In this recording, we are going to talk about an alternative to net present value called Profitability Index. In terms of the capital budgeting decisions it makes, it's actually the closest alternative to net present value. In fact, it's defined to be the present value of the future cash flows minus the cost. Remember, C0 is a negative cash flow representing cost, divided by the cost. That is, it's the net present value divided by the cost. It's also called the benefit, in terms of value, to cost ratio. The rule is you accept positive profitability indexes. That's the same as accepting positive net present value indexes, and reject negative. However, it ranks things in different orders than profitability index. Than net present value. It ranks them in order of net present value per dollar invested, not in terms of overall net present value. To do it, you need to find the present value of any given project. Then you find the net present value, then you divide by the cost. So for example, for A, the profitability index is defined to be the net present value. It's the discounted value of the future cash flows minus the cost, net present value, divided by the cost. In this case, recall that the present value was negative 9090 divided by 1,000, negative 0.0909. For B and C, it's a little bit more complicated, but your calculator actually makes it quite easy. What you need to do is discount each one of the future cash flows back to the day. So for B, for example, what you're going to do is discount each one of the 5 future cash flows back to the day, subtract the cost, and then we'll divide the whole thing by the cost. Now your calculator makes this relatively easy to do. You go to the cash flow functions in your calculator and enter the cash flows. $2,000 negative cash flow or cost today, $1,000 in a year, $1,000 in 2 years, $4,000 in 3 years, $1,000, and $1,000. First step is to get the net present value by pressing the net present value button. Enter a 10% interest rate, down arrow, compute. The net present value is $40.45. Then we'll divide by the cost. So 202 is a profitability index of B. For C, the cash flow in period 3 changes, the cost changes, everything else stays the same. Now we have $5,500 in year 3, a $3,000 cost. So under cash flows, we need to change the cost today and the cash flow in period 3. Net present value, interest rates 10%, compute, 4,172. Now notice, because you're dividing by a much larger number, this will actually give a smaller profitability index than B. Divide by 3,000, 1.39. So the profitability index rule would say B and C are both good projects. If we have to choose one, B is better than C. Now, one of the reasons we may choose one project or a limited number of projects is because of capital rationing. we don't have enough funds to invest in all the projects that we want to, and for some reason we don't borrow money to make the investments either. In that case, Profitability Index helps us by rank ordering projects in order of the most bang for the buck, the most value per dollar invested. So this can help us make decisions when we have a budget. Supposing we have $1 million budget and we have the following projects, A through F, with the cash flows in this table. If you reorder these things and rank them by Profitability Index, just doing a sort, and start buying the projects in order of highest Profitability Index to lowest until you run out of cash, in this case 400,000 project C, 200,000 project A, 100,000 project F, 200,000 project B, 100,000 project E. That exhausts the $1 million. Okay. And if we add up the net present value, it's 300, 400, 470, 555. You'll find that that maximizes the net present value across all possible combinations. And except for lumpiness of the projects and sometimes at the margins, this does a pretty good job of getting you pretty close to maximizing the total net present value. So Profitability Index is helpful for capital rationing. However, if you're only buying one project because of some other restriction, for example, they only let you undertake one project for regulatory reasons, or because you're doing it in a single space, then the Profitability Index is biased towards small projects. In our case, it chooses B over C. One of the things you can do is fix that with something called the Incremental Profitability Index. What you do with the Incremental Profitability Index is you consider both of the projects first. If either one of them is negative Profitability Index, well then you get rid of it. Then you consider the incremental investment required to move from a small project to a large one, and ask if the investment of those additional dollars is profitable. If it is, then you go for the larger project. So in our case, what we need to do is look at the increment. How much more do we have to invest to buy project C? How much more do we get for it? So what we're going to do is we're going to subtract the cash flows in B from the cash flows in C and get the net. We know that the Profitability Index is 202 and 139, but it's possible that investing that extra $1 million today is worth it. Whether or not it is depends upon the Profitability Index of the increment. So this is 3,000 minus 2,000 negative, that's negative 1,000. 5,500 minus 4,000 plus 1,500. Those are the only differences in cash flows. Now I'm going to go back and get the profitability indexes here. The profitability indexes were 202 and 139. Okay, now both these projects would be good if we can only invest one because of a shortage of funds. We invest in B. If we can only invest in one because of a space limitation or some other reason, we might want to invest in C because it has more value. How do you tell with profitability index? Well, as you find the profitability index of the increment, there's only one cash flow. You have to invest an extra 1,000. Let's just see if it's worth putting that extra money in order to invest in C. Well, this is a pretty simple calculation. It is 1,500 divided by, in parentheses, 1.13 times minus 1,000 divided by 1,000. 0.1269. That's greater than 0. So it's worth making the additional $1 million investment to bump up to Project C. It's not as high a return as the initial dollars invested, but it's still a better return than what you demand. So, Profitability Index gives the same accept-reject decisions as net present value. It helps in the rank ordering when you're capital rationing. It gives misleading answers when you're selecting one or a subset of projects for other reasons. For example, they might be mutually exclusive. But in order to calculate the incremental profitability index to fix that problem, you have to calculate the net present values anyway. So the question is, and we'll talk about this in class, why not use net present value from the start?